my KCSE Vision channel, Teacher James Marita, Girls Boys High School. Kindly subscribe to my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at mathematics form 4, that is matrices and transformation. And today we are looking at the transformation. So in our transformation, we have a point which is 5, undergoes a transformation. A transformation represented by the matrices 3 to -1, 0. This one is followed by the translation of -6, 11. Determine the coordinates of the image. So to get the coordinates of the image here, you say that let the coordinates of the image, let the coordinates of image P, X and Y prime. These are not the coordinates of this. We have let this one the coordinates of the coordinates of the image. Then we understand that we can use this formula that the coordinates of the image here is equal to the matrix of transformation multiplied by the coordinates of the object, then plus the translation vector. So you need to understand that this one here, this one represents the matrix. This is the matrix of transformation. This is the coordinates of the object. And then we have, this is the translation vector. So we have, this is a translation vector. As simple as that. So if we use this formula now, we can substitute because we have let our image to be that. So our image, it is x prime, then y prime, which is equals to p. The coordinates of the image is equals to the matrices of transformation. The matrix of transformation is 3. Matrices of transformation here we have is 3, and we have 2, -1, 0, like that, multiplied by the coordinates of the object. The coordinates of the object, the coordinates of the object is 5, 2. So this is, we have 5, 2. So we multiply this one by, this is 5, then we have 2, and this one we can add to the translation vector, which is -6, and then we have 11. So understand this one very well, that you can use the translation, you can use that formula where we are saying that the coordinates of the image is equal to the matrices of transformation times the coordinates of the object plus the translation vector. So if we can substitute that, we have x, y, which is the coordinates of the image, and then we have the matrices of transformation times the coordinates of the image plus now the translation vector. So if we work out that translation vector, we have this is 3 times 5 is giving us 15. So we have that one as 15 plus. Then we have 2 times 2, we have that one as 4. Next we have 5, -1 times 5. We have this is -5 plus 0 times 2. This one is giving us 0 like that. Then we plus -6, and then we have 11 like that. So this one will be equivalent to what? This is equivalent to 19. Then we have -5, of course, like that. Then we plus -6. Then we have 11. So if you add that, this one is giving us 13. We have that one as 13, and of course this one is giving us 6. So we are supposed to find the coordinates of the, determine the coordinates of the image. So the coordinates of the image coordinate now, we say that the image coordinates is 13, so we have this is 13,6. That's how you get the coordinates of that. Remember to use this formula that the coordinates of the object is equal to the matrices of transformation times the coordinates of the object plus the translation vector. That is when we have a transformation followed by the translation vector. That is the formula that you are supposed to use. Then we have number 2, the image of a point under translation. So we have the image of a point A under transformation represented by a matrix T. 1, -2, 0, 2 is A image. The image is -2, 4. Find the coordinates of A. So finding the coordinates of A here, we say that let the coordinates of let the coordinates of that A object, it is the coordinates of that A object, px and y. So this one you can write as x, y like that. So we can use this formula that the matrices of transformation times the coordinates of the object is equal to the coordinates of the image. So you will have the matrix of transformation multiplied by the coordinates of the object is equal to the coordinates of the, we have that one as the coordinates of the image. You can now substitute that if we have if we have in this translation, in this translation here, so we have this transformation matrices here, but we are supposed to find the determinant at that point. So to get the determinant here, the determinant of this one is the same as the leading diagonal minus the trailing diagonal. So the leading diagonal is this one. So this is what you call it the leading diagonal. Then you subtract the product of the trailing diagonal. So that determinant will be 1 times 2 is equivalent to 2. 0 times 2, we subtract 0, so that one will be equivalent to 2. So the determinant is 2. So the inverse of the determinant, the inverse in this case, the inverse of that is equivalent to 1. In that case, we have as 1 over 2. So we have the the matrices of that transformation. So in that case now, we have xy, which is a transform. So we need now the coordinates of we are supposed to find the coordinates of A. That's now the object. So we have the coordinates of A, which is xy. So we say that xy now will be equivalent to, it is the inverse of the matrices, which is a half, multiplied by now, we interchange now this one here. You interchange this one, so we have this is 2 here, then we take 1 here. On this side here, we normally change the sign. On the leading diagonal, we change the values, we interchange the values. So we transform these two, we bring it here, and then we transform one up to that side. That's on the leading diagonal. On the trailing diagonal, you normally change the sign. So this one is 0, -2. This one will be changed to +2. So in the changing like that now, you will have this is as 2, 2. And then you will have 0, 1. Then now this one is now multiplied by, we have been given the image coordinate, which is -2, 4. So multiply that one by -2, and of course we have 4. So if you simplify that now, you will get as 4, then 4 like that. Therefore we have the coordinates of the image, which is xy, is equivalent to p, a half, and then we have 4, 4, which is equals to P. A half times 4 is equivalent to 2. A half times 4 is equivalent to 2. So x is equals to 2. So we say x is equals to 2, y is equals to 2. Therefore, the coordinates of the coordinates of A image is now 2, comma 2, like that. It's now 2, comma 2. We have our next question is a transformation is represented by the matrices 1, 2, 3, 2. The transformation maps a triangle ABC of area 3 square centimeters to another triangle A image, B image, C image. So we are supposed to find the area of the triangle A image, B image, then we have C image. So the first step of solving this kind of a problem is by getting the determinant. So we have 1, then we have 2, then we have 3, then we have 2. That's what we have. So to get the determinant of this, to get the determinant here, the determinant is normally given by, that the determinant is normally given by the product of the leading diagonal minus the product of the trailing diagonal. So this is the product, the leading diagonal is here. So we have this is leading diagonal multiplied by, so you subtract the product of the trailing diagonal. In that case now, this one will translate to, we have 1 times 2 is equivalent to 2. We subtract 3 times 2, which is giving us 6. So if you subtract that one, it will give us negative 4. So the area of the image of this triangle is just the determinant multiplied by the area of the image, the area of the object. So area of triangle, so we have area of that triangle, the triangle A image, P image, then we have C image is the same as now. The determinant, so we will have the determinant multiplied by the area of the object. So we have this is the area of the object. The area of the object. So we substitute that such that we have our diagonal, our determinant here is equivalent to negative 4. The area of the object is equivalent to 3, and this one will give us negative 12, in that case, centimeter square. And since the area will not be a negative, we can ignore the negative. So in this case now we say ignore the negative sign in that case. Therefore area, so we conclude that area of A image, P image, C image is equivalent to 12 in that case, and then we have centimeters squared. We have the last part. Our last question is, the area of a triangle FGH is 21 square centimeters. The area of triangle FCH is 21 square centimeters. The triangle FCH is transformed using the matrices 4, 5, 1, 2. Calculate the area of the image of that triangle. So the first step is to get the determinant. So getting the determinant here now we have this is 4, then we have 5, 1, and then we have 2. The determinant of this one, determinant is equals to P. Determinant in this case is equals to P. The product of the leading diagonal, 4 times 2, which is 8. You subtract the product of the trailing diagonal, which is 1 times 5. So we have that one is 5, and that one will give us 3. So to get the area of the image of that triangle, So area of the image in that case, area of F G H image in that case is equivalent to, it is the determinant in that case multiplied by the coordinates of the area. So you multiply this one by area of the object. Area of object. So in that case now, the determinant we have as 3, the area of the object there we have as 21 square centimeters. So this one you multiply by 21 square centimeters, and this one will give 63, in this case, centimeter square. So that is how you can simply get the area of that triangle. So you understand, whereby we have a transformation, a matrices followed by transformation, like in case 1. Remember, use the formula. The image, coordinates of the image is equivalent to the matrices of transformation multiplied by the coordinates of the object plus the translation factor. We have come to the end of our lesson. Don't forget to subscribe, watch, and share.